devices are there. This is called ring state. Actually, this is a variable resistor. Okay, the second thing here, you need to do some basic information. Look here, the plane of the coil, magnet. Look here, this is your compass needle. In the compass needle, there are three things very important. Number one, here is the gray color magnet, rectangle shape. Its shape look like this. And you can see on the at this end there is a red color. Red color is there. And here is a pointer. This is called pointer. This is called magnet, and this red color means north. Red color means north. Same we will do second experiment with that magnet. This is called north pole, and the green color here today are sometimes blue or green, they are south pole, but red is always north pole. What is here? This is the dial, and here are some numbers you can see here. Might be here 30, 60, 90, then 0 like 60, 30, 0. Yeah, same 30, 60, 90, 60, then 30, then 0 like this one. These are some numbers. These are dial. So I'm talking about magnet now. This is a magnetic needle. This is a pointer. We say it's pointer. Number one, look here. Magnet. North pole and coil. There is a coil wire, one loop like a bisabralla, I will explain, and coil should align. Plane of coil, you can say that more easily, plane of coil. The second thing, pointer should be on 0 and 0. Both pointers should be on 0. This is our adjustment. Before doing this experiment, you have to follow these two information. You just do this first, and then we will start. What is the next step? There is a table. There is some constant. R radius of the coil. There are some constant. You need to be just right. This always be given. No need to find out. 15 centimeter. Today we are going to use coil with 50 turns. This is a 50 turns. And one constant we will use more here. Permeability of free space. In the first page they mention their value. 4, 5, 10 to minus 7 Tesla meter per ampere. Now here is the table. Ampere, current, then deflection, theta 1, theta 2, theta average, then tan of theta average. You will start 30, 40, 50 and 60. Finish. After that, you sketch a graph, and here will be tan theta average, and here is the current ampere, you will see some line. From this graph, you find slope. What will be its unit? Ampere. This is dimensional and here is the ampere. After that, magnetic earth. You can see the earth magnetic field here. This is our one question. This is called also K. This is the constant of this device. And the second earth magnetic field, that is H naught, here is some formula, mu naught n over 2r I over tan theta. This tan theta, I over tan theta, this is slope. Look here, this is slope. What is mu naught? Look here, 4 pi. This one from there. 7. What is n? 50. 2. What is r? 7.15 centi. And here you can put slope. You will get Tesla.
Multiplied by the slope.
Slope, yes. I over tan theta, actually this is a formula, and I over tan theta. This is a slope and this is called constant of Galvanometer. Constant.
Sir, should we memorize the constants?
No, formula you must memorize. Values are these values must be given in the question. Okay, follow me please now. Come here. Look here. Look here. Is there any difference between these two cable? Different.
Just
This is the lengthy, yes. This is short. So this device, we are unable to use this. If you use this one, then difficult to adjust your compass needle here. So keep in mind, for this experiment, we use these cables, number one. Clear? Second thing, there are many options here. This is just like a coil, nothing else, like a Biot-Savart law. How many turns are there now? 4. Right on, there are 4.
Yes.
So here there are many options. If you join these first two, it's a common. If you take this and that one, it means what is in between? 2. Then it's look like this. 2 turns, okay? If you use first and the third, what is here? 50. We are going to use their 2 terminals. But in future, if you use this first and then the last, it means that you are using how many turns? 500 turns. So this experiment we are going to conduct, just we use
50.
first and the third terminal. This is third terminal and here is the first. One thing, clear? And this is a compass needle. I told you here, this is the magnet inside, gray color, and the red color mean indicate the north, and these two right and left, they are arms, and here in the down there is dial, there are some numbers, reflections. Put here politely on the top, and this is the coil you see. This is the plane of the coil, plane of coil. Look here, this north pole towards me. And one thing might be on other table, it is north pole will be there, not towards here. Little bit change due to your mobile and due to some wire current flowing in the wire in the wall. There are some electric connections, so they produce magnetic field. So it is maybe different from here and there. So don't confuse. There are north is here and here in this case north is there. Do your own experiment just only. So this is the plane of the coil. Needle red color is towards me. To change from here, look here what I am doing now. Yes. Now this red color towards the plane of the coil. This is the plane of the coil. First, you can rotate this device Its name is Tangent Galvanometer. So you adjust it red towards the plane of the coil. This is the plane of the coil. Second thing, second part. Look here, where is the pointer? One pointer on the right, one is the left. Here in this time, this is on 10. It should be on 0, 0. Right now it is on 10. So just grabs very good from here. Now to move the base, you can rotate the yellow color. This is a dial. You can rotate. Look here, what I am doing here. Clear? You can rotate like this. So rotate until it's come to 0, 0. Clear? These are now two adjustments. Number one, red color of the magnet toward the plane of the coil. One adjustment. Second, just rotate the dial, not from the base of the device. Grip this very well from the bottom and then rotate this yellow color until the pointer right and left comes to 0, 0. After that, this is a new device for you. This is a variable resistor. Look how many terminals here, 1, 2 and 3, and one is on the other side. What is written here? This is the 100 ohms. 100 ohms mean we can produce resistance from this device from 0 to 100. If you are here on this side, right side, if you take this one terminal, black and the red, the resistance is 0. When you are moving away from you are here. So you are increasing resistance furthermore and more, and finally now becomes maximum, and its maximum resistance is up to 100. No need to use that terminal. If you use this that two black, it means that it behaves like a fixed resistor. That is 100 ohms only. And this yellow color and green color, not using today because we are not using with high potential. If you are using high potential, mean 100 or something more, you must turn this connect to the grounds, earth. So we are just doing experiment with 5 or 3 volts, so we can ignore this terminal, only here and there. What is this? This is one side connect with here. Voltage must be start from 0, we will do later. And we need another one wire. If it is positive, we can use, yes, positive for ammeter, and it should be 20 ampere. Look here, this is the terminal for 20 ampere, and here is a common put to here anywhere, and this red color one on the black. This is our circuit. And the second thing, this terminal should be away from you. Should be. When you start increasing voltage, you will see some deflection. After that, we will not change the battery. We can just reduce the resistance. If you reduce the resistance, current increase. And if current increase, you will see there is a more deflections. Clear? It's starting from here. Now turn on power supply. There is red main, there is a condition on the payment. You just move on the other side. Not for today. Now please tell here. Right now it is 0. Tell me again when it will be 30. We start from 30. So look here. Now, circuit is not connected well. Maybe there is some problem here. Okay, I will see. Maybe over the extreme. No. Okay, I will change the device. here. Here's the problem. Someone damaged this machine. Starting again from zero, beginning. First step. First step. Second, make it 0 pointer. Now increase voltage until the pointer comes to 30 on one side.
You turn off the battery.
Huh?
You turn off the battery.
Ah, take it, one thing is there. Yes, my point is there. 30 is there?
No,
How much?
it's 20,
Now?
25, 30.
Huh? Exact 30?
No,
Ah.
back,
Ah.
back, back more. Not exact, back.
I'm-
Okay, exact.
I was doing slowly. Mostly people, they are in a hurry. They do more quickly.
Yes.
So if slowly moves, maybe we need more time to, you may spend more time, but it will be more accurate. Okay, 30 is on one side. What is the reading on other side?
It's 35.
Exactly. Huh?
35.
Okay. It's not 30 exactly. Okay, 30 and 35. Here is 30, here is 35. So look here what I'm doing there. What is the current here? 30 and 35. 0.04. I think there is 0.04 current. Check this. How much current is there?
0.04.
Okay. Now look there. $50, 40.
40.
40?
Yes.
Exactly 40?
Yes.
41 side. What is on the other side?
Yeah.
What is on the other side?
No, little bit more. Little bit more.
It's okay?
You mean this side, yeah?
And one side.
One side?
One side 40 here. We first see there is a 30.
More. Little bit more.
Okay. 40.
Okay, 40.
And what is on the other side?
Other side is
Is
40, 40,
40.
45. 45. 45.
What is the current? 0.07?
Yes.
45. Okay, please come on now. Come here back. What is your place? What is here? Theta H. Add together, divide by 2. What is the answer? 35 plus 30. Theta 1 plus theta 2 divided by 2. This is the average. So you will see there is 32.5. Same like 42.5. You will do the X next. What is this? Tan theta. Calculator button. Tan of this number. Tangent of this number. Sine, cosine, tangent. Tangent of that number. Please write it some value here. Then sketch a graph. Find the slope. This slope is from your graph, not from your own calculations. Then use that formula. Put slope here And this is the constant, n is the constant, r is the constant. Do your calculation. You need to do the test. Okay, please carry on. Do as soon as possible and we will start the second experiment.